Hello and welcome to day 2 of the Robotics and AI Showcase. Yesterday we had really good engagement and we look to lots more of the same today. So this first session today is the Making UK Manufacturing Smarter session. And I have with me Chris Courtney, who is the Challenge Director of the Manufacturing Made Smarter ISCF, the Industrial Strategy Challenge Fund programme from Innovate UK. We also have a number of other speakers. But essentially, so my name is Nicole Ballantyne. I'm working the manufacturing team at KTN. I have 25 years of manufacturing experience working in factories, and my role at the moment is to work with Chris Courtney and his team at Innovate UK to help build a diverse community that engages in innovation in the industrial digital technology space. So today's session is specifically around the challenges and opportunities when bringing new robotics and AI solutions and products to market. And hopefully you'll gain some insight into how to approach new product innovation in this space. As I say, we've got 3 guest speakers. They are Dave Swan, who's the CTO of Tharsis, who will be talking about de-risking the new product innovation. Kieran Singh, who's the senior data scientist at Tharsis, and he'll be giving a bit of an insight into digital tech and how that brings a real laser sharp focus into your commercialization journey. And then we'll be talking to Alex from BrickBots, who will talk about his journey around securing private funding through his own experience. So now I'm going to introduce Chris Courtney to tell us a little bit more about the Manufacturing Made Smarter Challenge and how that will help innovators in the technology space to support UK manufacturing. Chris.
Thanks, Nicole, and good morning all. My name is Chris Courtney, as Nicole said, and I'm the person responsible for the challenge around Made Smarter and the innovation programme. And what I'll do for the next couple of minutes is just explain a little bit of an overview of the programme, what it is, and then maybe start to finish on some challenges and some opportunities around the technology side of things and how people across robotics and AI can support this programme and get support from it. And so just a little bit of introduction to it. So for those who aren't familiar, there was a lot of work done 3 or 4 years ago around digitalization of manufacturing. There was a report published in 2017, which was called Made Smarter, which really highlighted the relationship between digitalization of manufacturing and supply chain issues, and then how that can impact issues like productivity, resilience, flexibility, sustainability, and so on, very broad range of parameters within manufacturing, and identified some key technology areas that where there are some UK strengths, and there is an opportunity in business to adopt some of those. And while a lot of that report is fundamentally sound and true, I think we can all think of all of the things that have happened in the last 4 or 5 years and the disruptions that are all around us and the impact that has on manufacturers, both in a positive sense, but also clearly presents some difficulties, particularly around the pandemic. So what this challenge is here to do is to try and tackle digitalization of manufacturing and supply chains. It covers all manufacturing businesses from food, pharmaceuticals, aerospace, automotive, chemicals, textiles, you name it. And one of the fundamental principles behind that is the fact that digitalization is a common issue across all of those sectors. In detail, each of them have some really exciting opportunities and exciting challenges. If you think of the challenges around food and sustainability and resilience around food supply chains, the move towards synthetic production of foods and so on, and how do you transform that whole food production process to cell and gene therapy and pharmaceuticals, electrification and autonomy within automotive, sustainable aviation, and the list goes on. All of those sectors are undergoing pretty fundamental transformations, and that's before you layer on top the pandemic, Brexit in the case of people in the UK, and so on. So there really are disruptions happening across all the manufacturing sectors, which presents opportunities and obviously challenges for the people who are in those businesses. And I think it's the same from the technology side. You then consider the role of digitalization in all of those challenges and realize it's fundamental. So a lot of the technology that we're talking about in this showcase is a fundamental enabler to achieving some of that. So, it's hugely important, and I'm delighted to say have this program of work that we have. The program itself focuses on those manufacturing and supply chain issues. It's 147 million of government investment. If you roughly double it, it's 300 million. And we are busy doing a range of things. We've had funding for about 9 months now, so September last year. We've launched some competitions under collaborative R&D programs. We are about to announce investments in research centres, which includes areas around robotics and artificial intelligence, where we've selected the people who are going to go forward with those. We've got technology accelerators, which are fundamentally about trying to get technology startups engaged directly in industry challenges and to really sort of boost their journey, and so they can become scale organizations, and a range of other different measures. You know, we're very busy trying to do some of that, and behind all of that, trying to create a connected ecosystem where large and small technology developers, large and small industry, academics, and so on can really come together to generate the next generation of solutions and so on that we're going to need to try and deliver on the promises of the future, as I say, but across all of those sectors, which are really disrupting at incredible speed. So I think, you know, we're trying to sort of build that total ecosystem. I think if you look at the Made Smarter report, a lot of it talks about impact for manufacturers. So it's focused on productivity and resilience and those kind of issues. We all understand, particularly in the last 12 months, why that's become hugely important. But there's the technology provider side of that. One of the questions that exists is, which bits of this should the UK really invest in? Where can we really have strengths? Where do we have the technical skills, the entrepreneurial skills, and so on, the financial investments, and so on? Where can we really make a success of that? And I think you'll see from Dave and Kieran and Thorsos, you know, just as an example, a really strong example of where the UK can innovate, where it does have strengths, where we can build on some of that. If you look at the data, robotics and AI actually are two strongly invested areas, whether you look at university investments, private sector investments, venture capital investments, you look at patents developed and so on. So robotics and AI really are cornerstones of capability for the UK. And there's enormous opportunity, I think, to try and develop that. So for our manufacturing businesses, we're really keen to see how we can do more of that, not just to say, so the manufacturers adopted and so on, but actually that we can grow the technology sector that enables some of that. We have developed a technology strategy that kind of informs some of that. We have pulled together a group called the Tech Founders Group. We really want to hear directly from people who've lived and breathed that journey of trying to grow technology businesses. And so we'll continue to invest in things like technology accelerators and innovation hubs and other environments, as you'll see over the next few weeks, to try and create the environment for those technology companies to flourish. And I think, you know, given the disrupted times we live in, the opportunities are enormous. But there are challenges still in terms of finding funding, finding industrial partners to work with, and so on. And we'll try and sort of piece that together to try and build an overall integrated community, if you like, that will really boost what UK manufacturing can do and boost the technology sector that enables that opportunity. So it's hopefully you'll see a lot more of what we're doing. And if you haven't been engaged directly in the manufacturing side, please reach out to myself, to Nicole, to the team. Come find us. Many people do for more information, and we'd be happy to talk you through the opportunities that we do have and find out more about what you're doing. And with that, back to Nicole.
Great, thanks, Chris. And I guess the main message to bring away from that is that there is still funding available through the Innovate UK programme, and we've got a collaborative, I was going to say CR&D, a collaborative research and development programme coming up towards the back end of this year, and also, you know, as Chris mentioned, there's the accelerators and the research centres, and all those programmes are happening right now. Madesmarter.uk is a good point of resource, or the KTN website, Google KTN and manufacturing made smarter, and you'll have information there. Or, as Chris said, just link with us directly on LinkedIn and we shall help you and point you in the right direction. So on to our first panelist, Dave. So Dave Swan is the CTO at Thorsos, and Dave will be talking about de-risking new product introduction through diligent commercial and technology strategies. Dave's going to talk a little bit about the commercializing innovative technology, particularly hardware, and that requisition for financial risk. He's going to give us a bit of a reality check on the stages to commercialization, focusing on the proportion of funds needed where those might come from. And then he's going to give us a bit of an insight into understanding the development process and the cost hockey stick. So over to you, Dave. Thanks ever so much.
Hi, I'm Dave Swan from Tharsis. Maybe some of you will remember from my talk at the last one of these sessions. That was in the real world. Can't wait for the next one to be in the real world as well. Last time I gave a talk about innovation and hacks and tricks, a way to go about approaching innovation. So I'd like to refresh on that and then unpick that a little bit more in relation to hardware. So last talk I gave was my little simple phrase of get clarity of outcomes and go for it. And in that, there was three really simple themes coming out of that. The most critical thing being outcome. The thing that you are absolutely certain is the purpose of the innovation you're about to undertake. So in the context of hardware, what is the thing that this product is going to truly deliver? How's it going to make a difference in the world? Why is someone going to be desperate to have it do that for them? And as a result of that, that gives you a really, really solid foundation to get you through the hard days of innovation, because trust me, it's hard. There will be down days, there will be up days, but there'll be down days. And it's really important that you have a really, really solid understanding of that massive, great big prize that you're entitled to as a consequence of this innovation and product development that you're going to go under. The second critical factor in there is time. You are, when you're developing new product, you are fighting the clock all the time, because you are inevitably doing something which is transformative, it's new to the world, and you've got to get it out there. You've got to get out there for two reasons. One, you need to get out there and prove and get payback for all of your effort that you're putting in. And secondly, probably more importantly, you need to get it out there so that your customers and your users can give you some real feedback as to the value of the product or the features of the product and the uses of the product, because they're the people who are going to really see the value in it. So they're the ones who are going to give you that feedback. So you really need to make sure you get there as quickly as possible with as fewer steps as possible, so that you can concentrate on that really critical feedback that you're going to get from the market. And that sort of leads you to that third leg of the challenge, which for us is about risk. And it's about making sure that you can eliminate as much of the risk as you can, as early as you can. And that's predominantly driven by the fact that not all risks are born equal. For us, we try desperately to focus on what we would describe as the sort of the project killer type risk. If you imagine that the development activity you're going to undertake is a bit like the game of snakes and ladders, a project killer is that really big snake that sits on that board that when you hit on its head, you slide all the way down to the beginning. That a lot of the effort and the money and the time that you've put in has been wasted because the thing that you didn't know about has come true. The thing that you didn't do has come true. So for us, it's really about trying to get hold of those risks and get hold of the big ones as early as possible and eliminate those, so that you know that you are fundamentally entitled to that really juicy outcome that you've identified, and you're going to get there as quickly as possible, and you're not going to get tripped up along the way by something that's going to completely derail you. So that was my theme last time, and this time I really want to sort of unpick that a little bit more in relation to hardware and why it's so critical to hardware. And I think for me, it's the core difference between hardware development and software development is the cost and the consequence of iteration. So in a software environment, most people who are writing software or will be contemplating making a new software product, you'll be operating in a really agile sprint fashion. You'll have incremental changes, and you'll be, maybe, I don't know, hundreds, thousands, maybe even 10,000 different iterations of product from that first concept all the way through to product development and product release. But in a hardware world, that's just simply not possible. Any one hardware step requires so much more coordination, so much more time, effort, interaction with real world components and specs and changes and costs, that, you know, each change is 10, maybe even 100 times more expensive or have consequence than in the software space. So that means that you don't have as many steps. You can't make as many iterative steps along the way because you simply can't afford it in terms of time or money. So, you know, in best case, you're going to see something like 10 steps between your concept and your finished product, but more likely like 5 main steps, we imagine, between that. So it's absolutely critical that you try and get real clarity at the beginning before you try and go down that journey. And one of the other reasons for that is because in a hardware space, each one of those steps gets progressively more and more expensive. Therefore, further you get down there, the more invested you are, and therefore the bigger the consequences of falling back down that snake, back down to the beginning, because as you start to get further down, things to get really expensive. What do I mean by that? So I think in our world, we consider there's sort of 5 steps, holistic steps, between the beginning of the idea to a product into market. So we have sort of a concept phase, then we would go on to a mule phase, and then you're into the prototype and the detailed design phase, and you have a pre-production phase, and then you're into production. 5 simple sort of steps. And every single product and every single project is totally different as to how long and how much those take. But as a simple sort of rule of thumb, which I won't stand by when anyone comes to us asking to develop a product, but just as a sort of a ready reckoner to understand relative sizes. If you take that first step of creating the concept, if you just sort of set the recognition of effort there at the value of 1. Yeah, so if you say that's 1, whatever that is, time, money. Once you get through that concept phase, then in that mule phase where you are knocking together some concepts, you're proving out that you're entitled to it by validating it a little bit in the market, you've stuck some components together, you've written some quick code to make them do what they've done, you've made some CAD renders. We reckon that's probably about 3 times more cost than the concept phase, because the concept phase is very desktop based. In the mule phase, you're into physically doing something. You know, you're working in the workshop, you're making the product. By the time you get to the end of that phase, you've got a specification in mind. You know how it all hangs together, and you've convinced yourself you've got an entitlement to success. And then you're into the prototype phase. Now, in prototype, that's when you're putting some hard effort into the detailed design. You're starting to engage engineers. You're starting to engage the full scale of the sort of the development process. And as a rough rule of thumb, we think that's about 6 times more than that original concept phase. So you don't want to be going into that phase lightly, and you definitely want to be coming out of that phase with some confidence that you're going forward, because now you've invested 10 times that original sort of concept time, and you don't really have a product yet. You've only got a prototype. And then the next phase that you go into, it starts to get progressively more expensive. So in that pre-production phase, when you're talking about laying down tooling and you're doing some really heavy testing of your product, you've got some pre-production samples, you've got a really expensive early batch of product being created. That can be like sort of 12 times. So you're now up to sort of 20, 22 times as much as it cost you to do that first concept. Now, if a problem comes up now that's a project killer, you have consumed a lot of your resource and a lot of your motivation and your energy to get to here. So, it's all building up and building up. And that's before you get into the heady days of production. Because when you get to production, very product dependent, but you could be contemplating sort of 20 times, even more than that, in terms of, now you're into laying down commitments for components that you're going to have to secure to be able to make your product with. everyone's heard of the chip shortage. We're getting 52-week type lead times being quoted to us at the moment. So to secure your ability to produce, you're going to have to make commitments to that type of stuff. What are you going to need in the next year? You're also going to have to be laying down commitments for labor, facilities, plant availability, just the ability to actually convert those components into products. That's before you even start contemplating all of the costs inside your bigger business around getting a product into market, with all of the marketing and all of all the support services, your customer services, etc. So you can see how the costs really ratchet up, particularly in a hardware space, which is why it's absolutely critical that you get a really clear view and a clear entitlement to success at the beginning, and you de-risk it as much as humanly possible. Because it gets really expensive, and you have to be absolutely certain that the destination you're trying to get to is really worth it, and it's really going to be that jumping off point for your business or for your product idea, and that you've convinced yourselves in the early phases. For us, it's critical that you, in that mule phase, you've validated that you're entitled to the solution that you're planning to take to market and planning to create. If you're crossing your fingers and you're hoping that it's going to be okay, then something will trip you up. So it's important that you've got all those project killers out as early as you possibly can in that phase. And to a degree, I think you have to be absolutely certain in that destination that you've got a market to go for, because it's all about that destination. And I think the one reason why we really emphasize that sort of that concept or that destination at that mule phase is because however high you set the bar at that end of that concept and muling phase, conceptually that's as good as the product's going to get, because at that point your tires are hitting the road, you're dealing with the real world consequences, you're making compromises, you're making it all kind of work, etc. So the bar has been set as high as it can possibly be set in that early phase before reality strikes. If you're hoping to add features and add stuff as you go along, it just won't happen. Inevitably, your product in its purity will get worse as your product goes on. It won't get closer towards that lean optimum solution. So the more time and effort you can put up front when the resource requirements are low and the commitments are lower, that's the way to guide towards success. Now, Kieran's going to talk now about some of the techniques and tools that we've developed and are learning around how you can try and bring some of the software agility into that hardware space to try and load the dice, as I said in my last talk, towards making innovation having a higher probability of success. So at this point, I'll pass on to Kieran.
So I would like to build on Dave's theme around product development challenges and weave in where and how digital technologies empower the product development cycle. Number one, we can see into the future. Dave has talked about setting the bar as high as possible at concept stage, but really we would love to peek into the future to understand the validity of the concept itself, requirements, constraints, assumptions. So with the digital solutions we have to offer, we can predict outcomes even before we get started, and then at every subsequent stage. That's really our aspiration, but the question is, how do we do it? If we break down the digital technologies offering, it really comes down to 3 buckets. Number 1, simulate. Number 2, emulate. Number 3, test. In simulate, we can build models. Emulate, we can build software. Test, we get to test the outcomes of these models and software that has been developed. And of course, you do this iteratively several hundreds and thousands of times. What I'd really like to do is bring these 2 concepts to life through some examples from Tharsis over the past year. Number 1 is this example of Bump, where we developed a product right from scratch based on an immediate need. So I'd really like to talk about how digital technologies has helped us in that process. And the second is around work that we've been doing in robotic swarms in complex logistics systems. So to get started, we just look at the Bump example itself. Where did it come from? We were all there. March 2020, we went into lockdown. And the question that was posed to us by THASA senior management was, can we bring people back to work safely? And BUMP was really born. My colleagues went away, had a think, and came up with this concept of BUMP. Really, what is it? It's basically a database social distancing device. Requirements include it must be reliable, wearable, allows us to alert if another individual has come within close proximity. It's cheap. We use off-the-shelf technologies. It should be energy efficient, reliable, simple, easy to use, and robust, crucially, because we work in a manufacturing environment. So the technical solution that came about is it basically a peer-to-peer communication between devices. If two bumps come within about a meter radius of each other, the red LEDs flash and there's an audible alarm. If they come within 2 meters, the blue LEDs flash and there's an audible warning. And inside this little device, which is about 10 centimeters in diameter, there's a couple of sensors which have been strategically selected, the complementary sensors, which allow us to achieve our optimization requirements of which are basically competing aims. We want to be accurate, we want to be responsive, we want to use as little energy as possible, and the objective of our device is to be able to select basically tune parameters that allow us to achieve these objectives. So the logic itself is really simple. We've laid out the core logic itself. The devices will seek each other, they will advertise, they will scan. Once you've created a long list of potential devices to talk to, the real challenge becomes which is the one threat to be sifted out of hundreds of devices potentially in the background, which are a safe distance away. Once the devices decide to talk, they will then measure the distance between each other, and based on the outcome, the UI will light up. So really what we've done with digital technologies is applied our simulate, emulate, test approach to try to come up with an effective device sorting logic. And that's really been the real power of the solutions that we've had to offer, because we've been able to do this in a software environment. We've tested multiple variants and come to basically find our sweet spot, where now we have a working bump device. The second example is almost at the other end of the spectrum. This is in the complex logistics environment. And what we've been looking at is trying to find efficient automation solutions in these logistics environments. One particular environment that's of interest is the container shipping one. Container shipping is basically 90% of all shipping traffic, and container ports can be extremely busy, complex logistics environments. There's a lot going on. Time is literally money at these ports. And it's actually led to these automated container terminals, or ACTs, that are designed for automation for continuous, so that you can basically continuously improve. And the crux behind continuous automation is managing the machinery that handles containers, offloading from ships. The schematic on the right-hand side shows some example of the kind of machinery that is involved. So basically, when a container on a container ship comes in, even before it's offloaded, its destination would be known, and therefore the key crane would offload the container to the bay. There's an automated guided vehicle which would then negotiate with other partner AGVs a route to the yard where that particular container would go. Deposits it at the yard lot, and the yard crane then takes over. And once the lorry shows up, it'll then transfer the container over to the transfer point. So the whole point around the logistics management element is to try to work through the logic to make sure that you get to this to the business objectives. You want to minimize time to unload. You want to minimize operating costs. You have a bunch of tuning parameters that you could potentially tune. The simulation approach is really what we've managed to leverage here, because you've got a massively complex environment, and really what you're trying to do is de-risk as far as possible without having to put in a bunch of cost. And logistics problems can be, logistics environments can be very capital intensive. So simulations really work quite well here, particularly initially. The approach is essentially what you'd be doing is trying to define a model, make some assumptions if data is not available. You then run the simulations. If you've achieved your targets, you then potentially have to update some of your assumptions. So you run thousands of iterations to try to get to a point where you can actually talk to a customer. They themselves will have their own feedback. So that loop, that sort of virtuous cycle continues until you reach a point where you get a client specification. And at some point, we'll find that we've reached a specification that we can give to the software team. So now we can incorporate the emulate element into our approach. But this is fundamentally really why this is so powerful, that you can run all these simulations in a completely automated, in a completely offline setting before you invest heavily in a capital-intensive project. So hopefully we've been able to give you some sense of how we manage digital technologies into our product development cycle at Tharsis. And I'd really like to just sort of return to our recurring theme that David brought up on the importance of getting clarity of outcomes and then going for it. And what we're saying with digital technologies is that we can help you see into the future and really accelerate towards it. But the way we do it is by managing the three crucial considerations that Dave alluded to. Number one is outcome. What we can do is understand product performance through simulations, through emulate, through testing, even before you build it. The advantage is then you manage to accelerate the product to market journey, and that addresses the second crucial consideration of time. And the third massive advantage is we're able to identify project killers, weed them out, and potentially mitigate it against them, and therefore help de-risk the problems itself. Hopefully, that's giving you a good insight into how we try to work at Tharsis. I'm going to wrap it up here, but thank you for your time, and we're happy to take any questions. Thank you.
Thank you so much, Kieran and Dave, for those really, really great insights. Every time I hear somebody from Tharsis talking, I kind of recollect reading about you and about your journey as a company, and coming from a sheet metal worker, how you were formed, and where you've innovated in your business, so your business strategy, as well as that model of being a collaborative partner to bring new products to market. And what you've just spoken about is really great insight, and it's great that you're sharing that knowledge with the whole community. So next is Alex from BritBots, who's going to talk about securing private funding. He's going to give a little bit of perspective on how to increase the chances of securing private investment, and some of the challenges in securing investment, and explaining really the investor preferences for robot hardware versus AI software. So over to you, Alex.
I'm going to be talking to you today about how to fund the commercialization of your robotics business. Before we kick off, by way of introduction, BritBots is a venture capital fund that invests in early stage robotics, AI, and artificial intelligence businesses in the UK. We invest in about 6 businesses a year, between £200,000 and £500,000 in each, usually as the first check into the business. And we focus on companies delivering large scale productivity improvements, which kind of ties into our overall kind of macro thesis of this being important in a world of increasing consumption but falling resources and shrinking skilled labor pools. So since 2017, we've invested in 25 companies spanning industries like construction, agriculture, transport, and the environment. And here are a couple of them down here. But you can check out our website for some more details of what we've invested in. So today, since we don't have much time, I'm going to talk about two main things. First of all, why it's important to think about raising private capital in addition to grant funds. And secondly, what private investors are looking for when you want to raise capital from them. First, a quick word on public funding. Obviously, it would be foolish not to constantly be on the lookout for grant funding, given that it's essentially free money into your business. But equally, it's very important to realize that since you're not going to be able to purely build your business with public funds, you should always have your eye on convincing private investors to partner with their cash as well. You need to kind of wear both hats. And there are three main reasons really why grant funding isn't going to be enough. Number one, it's uncertain. So only about 7% of Innovate UK grants are successful. And the project you're working on may not have a compatible grant application to apply for, or grant to apply for at the right time. So we have some companies who start off needing private funding before getting to a position where they're even able to apply for applicable grant. Secondly, match funding. Even if you do secure a grant, you'll be able to, you won't be able to totally rely on that funding. You'll often have to match the funding with between kind of 30 and 50% of private funds to unlock that money. And in any case, the grant funding isn't really going to take you the full way. It's going to be pretty unlikely that you'll be able to get to a position where your cash flow is going to be able to self-fund you. So private funding is going to have to kind of take up the slack at some point. So if grants aren't going to be the panacea for your business, thinking how your business will attract private sources of capital is very important. And the key thing here is to remember that what makes you attractive in a grant application is not necessarily what makes you attractive to a private investor. So broadly speaking, when you're making a grant application, the focus is really the product, performing R&D, and achieving some form of technical proof for your product. Whereas private funding is looking for more than that. They're looking for commercial proof. How can this be a great business? And this evolution between public and private funding is to shift the focus of your business from a pure product focus to a more kind of holistic customer focus. And so, obviously, private funders or investors do care about product, but they want to understand how this is a foundation for you growing a valuable business. And we read loads and loads of presentations where 90% of the presentation may just be on product, without really much focus, or at least sufficiently less focus on the other elements that are crucial to making a business valuable. So why move beyond product? Well, really, private investors want to avoid the situation of investing in something which could just turn out to be a science project. We want to establish as quickly as possible that customers actually want to pay for this product in the real world and switch their behaviors from what they're doing already. And we've seen loads of examples of founders that are so obsessed with perfecting their product, they never even get to market. Founders who don't interact with potential customers early, so end up creating solutions at problems that don't really exist at sufficient scale. Or founders creating solutions for customers which customers like, but it's at such an expensive price that no adoption actually ends up happening. So I think number one takeaway here is, start thinking about customers as soon as possible. Don't think about your product in isolation, but think about how your product is going to interact with the market. And this isn't just important to give you proof points, it's also important to kind of create tangible proof points for an investor that progress is being made, progress that can be tracked is being made. So what are some other things to think about? Well, There are several qualities that a private investor wants to see in a business, most of which are obvious and loads of people have spoken about tons before. Obviously, great product, great team, massive potential market. But I think there are two things that are often not focused enough in sufficient depth, and that's scalability and defensibility. In terms of scalability, I'm referring to a company's ability to use investment efficiently to drive any combination of future revenue, customer, or profit growth quickly, and therefore to grow the value of the business. And one of the reasons why a lot of investors are less keen on hardware investing, like robotics, and I'm sure lots of you have come across situations where you'll be told that, you know, X and Y investor isn't investing in hardware at the moment, or you know, it's not their policy to invest in hardware. But it's based on a reason that they believe that hardware investing will require significantly more investment and be slower to grow than software businesses, and as a result be more dilutive on their investment. So really, in the context of a conversation with an investor or a pitch, whether explicitly or implicitly, it's really important to try and dispel this kind of scary paradigm applying to your business. Obviously, there are lots of different ways of doing this, but three kind of things to think about here. Number one, hardware costs. So, you know, try and ensure that these aren't too extreme. You know, and obviously this is a lot easier today when you can get, you know, off-the-shelf hardware, or put these costs in the context of the business as a whole. So how is your business more than just a hardware business? Business model, try and make your business model more than just about robotic sales or robotic unit sales. You know, is your hardware actually a route to a much larger scalable software layer? Can you drive recurring revenue from robotics as a service subscriptions? Do you have a pipeline of additional software services which could act as revenue generators and can be bolted on to your initial offering? All of these things are helpful to kind of broaden the picture for the investor and realize that actually robotics are often a very defensible way of selling a whole suite of services, rather than just that kind of paradigm that you're selling a piece of machinery. Finally, distribution. What are your routes to your initial customers, and how do you plan to generate initial sales? And do you have any examples of initial conversations, trials, unfair ins into the market you're trying to enter? It's very rare that you will build and they will come, and so it's important to kind of allay fears that you're going to just kind of release a product into a vacuum. Then finally, on defensibility, I mean, what do I mean by that? I mean, if you're you know, even if you're solving a massive problem that customers are willing to pay for, and you can grow this business quickly, investors want to know how you can defend yourself against competitors. Obviously, if you're developing hardware, one of your main advantages is the ability to protect your IP through patents. But there needs to be an assumption that if you're successful, you know, people are going to try and copy you, and patents often aren't enough. You know, so how do you kind of create some defensive qualities inherent in your business, other and aside from just kind of IP protection? Well, obviously, lots of classic defensive qualities like brand, economies of scale, pooling resources, having switching costs inherent in your business. But I think one of the strongest qualities which robotics businesses can use to defend themselves is ensuring that their service, the service that they provide, increases with every new user that joins their system. In network businesses like LinkedIn or Facebook, network effects have often been spoken about, and they're obviously brought about through the addition of new connection points to that network. But in automation businesses, incremental improvements of services can really be based on data collection from every incremental user. And this can really be a fantastic basis for defensibility. It gives you the ability to improve your products. It gives you the basis to get insights to stay ahead of competition, to gain insights to develop new products and new revenue streams, and it can't be copied in the way that hardware can. So that was a kind of whistle-stop tour for 10 minutes, and I hope it's been helpful for giving a few pointers on the importance of considering private funding and also what kind of thing private investors are looking for. If you're looking for early stage funding for your robotics or automation business, please get in touch. My email's at the bottom of the screen, alex@britbots.com, and yeah, it'd be great to hear from you. Thank you.
Great, thanks so much, Alex, for that insight. And I think what's great hearing from you is, it's from the horse's mouth. You investing in these technologies, you've got that experience of investing in these technologies, and you know what you're looking for. And so to give that insight is just invaluable. So thank you so much. So we've run out of time actually, but Q&A, there has been some questions coming in. What I'm going to do now is I'm going to go over to the collaboration room, and we'll do the Q&A in there. So it just leaves me to say thank you so much to Chris, to Dave, to Kieran, and to Alex for your time and your insights today and sharing with this community. And we look forward to working with you again soon. So